And this video will have two examples of solids of revolution. The first volume of solids of revolutions. The first one is we want to find the volume of a solid, the solid. That's obtained by revolving the region bounded by y equals 1/4 x squared and y equals 5 minus x squared about the x-axis, revolved about the x-axis. Okay, the first thing we need to do is be able to sketch the graph. We set the two functions equal. 5 minus x cubed, now x squared. So we're going to bring the x squared over to the left. So we get x squared plus 1/4 x squared equals 5. 5x squared over 4 equals 5. This gives us x squared equals 4. So that's x equals plus or minus 2. Let me divide this up so I can use the rest of the screen. So x equals plus or minus 2. So when x is 2, we can plug 2 into this function or this function and calculate the y value. When x is 2, 1/4 of 2 squared is 1. And when x is minus 2, 1/4 of 2 squared minus 2 squared is 1 also. So 1, 2, 1, 1, 2, 1. So the graph of the first curve, y equals 1/4 x squared, looks like this. That's a parabola. Y equals 1/4 x squared. And the other graph is also a parabola turned downwards, and 5 minus x squared. So it's minus x squared 5 units up. So 1, 2, 3, 4, 5. It goes through these 2 points, through this point and this point. So that's y equals minus x squared. It's shifted up 5 units. So this is y equals 5 minus x squared. Now, this is the time when we see the axis of revolution. We pay attention to the axis of revolution. So now we have the graph properly done about the x-axis. So we're revolving it about this axis. So we're going to take a generic x between minus 2 and 2 and make a segment. And we're going to revolve this segment. So x is on the way, so I'm just going to put the x away here, put it x. All right, so this far out from the x-axis up to this far out from the x-axis. That's 1, 2, almost 3, about here. So what I get is this cross section becomes a nice little washer. So I'm going to need the big radius and the small radius. The big radius is just simply from the x-axis up to the green curve. The green curve is y equals 5 minus x squared. So the big radius is 5 minus x squared. And the small radius is from the x-axis up to the graph of y equals 1/4 x squared to this point. To this point. From here to this point. And that's just simply 1/4 x squared. So the volume is pi, the integral from minus 2 to 2 of big R squared minus little r squared dx gives me pi, the integral from minus 2 to 2 of 5 minus x squared quantity squared minus 1/4 x squared quantity squared dx. Let me rewrite that. Pi from negative 2 to 2 of 5 minus x squared squared minus x squared over 4 quantity squared dx. We need to FOIL this and integrate. I'll just write down what you get when you FOIL it. Minus 10x squared plus x to the fourth minus x to the fourth over 16 dx. If you integrate this, the final answer comes out to be 173.6 over 3 pi. So that's going to be the final answer. All right, let's go on and do the next example. In the next example, we'll be taking the same region as number 5, but we're going to revolve it about y equals negative 2. The y equals negative 2 line is this one, okay? But the region is the same, so we can take a generic x on the region and make a segment at x and revolve that segment about y equals minus 2. Okay, so we're going to duplicate this segment over on the opposite side of our axis of revolution. So we're going to measure, so this is like a mirror. We're going to measure this distance. That's about 2.5. So that's about 2.5. And we're going to measure this distance to go from here all the way. Or we're going to measure this distance to go from here all the way. Okay, so about, let's see, 1, 2, 3, 4, 5, and a little bit. 1, 2, 3, 4, 5, and a little bit. It's about here. So my cross section, so revolving the object of about the line y equals negative 2 and cutting it at x, the cross section would look like a nice little washer here. This one is a wider washer compared to this guy here, because this one is revolved around the x-axis, so the distance from the x-axis to from the axis of revolution to the graphs is closer. All right, now we're gonna need big R and little r. Well, for the big R, we measure that much. We're gonna measure this distance. One thing we know is from this point to the x-axis, the distance is 5 minus x squared. And our graph here, our axis will add 2 more. So from here to that is 2 more units than the line from the distance from the x-axis to the point. So that distance, big R, is 2 plus 5 minus x squared. Same kind of thought, from here to here is 2 units plus the distance from the graph to the x-axis. From the graph to the x-axis, 1/4 x squared. So that gives us 2 plus 1/4 x squared. So that's the little radius. Okay. So what do we have? The big radius is 7 minus x squared, and the little radius is 2 plus x squared over 4. So the volume is pi, integrate from negative 2 to 2, because x could be anywhere from negative 2 to 2. We don't get to see, this is not relevant. We don't see that, because that's taken care of when we took the functions, okay, with the radius. The length of the radius took care of that height. So we're taking the integral from negative 2 to 2 of big R squared, that's 7 minus x squared quantity squared, minus little r squared, 2 plus x squared over 4 quantity squared dx. Okay, well, we're going to have to FOIL this and integrate. I'll just give you the final answer here. The final answer you're going to get is 112 pi. All right.